Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on July 30th, 2025, just 2 days ago. This paper introduces a new Python library designed to make 3D visualization for computer vision and robotics much more accessible. The paper is titled Viser Imperative, Web-Based 3D Visualization in Python, and it aims to make debugging and understanding complex 3D models much easier. It does this by combining a powerful set of 3D and 2D tools with a web-based viewer, all controlled through a straightforward programming style that should feel natural to Python developers. And it's already getting some nice attention online. One of the authors, Zhenjun Zhao, posted about it on X, and his post is pretty straightforward. He shares the title, and then adds a little joke, saying the too long, didn't read summary is basically just the title itself, which really speaks to the clarity of their goal. The post includes a great collage of images showing what the library can do, things like visualizing complex point clouds, robotic arms, and even animated human figures. It's clearly a versatile tool. Diving into what this looks like, the authors show several computer vision examples. We see monocular 4D reconstruction, which is building a moving 3D model from one camera. Another panel shows camera poses within a dense point cloud. They also feature an interactive viewer for a skinned multi-person linear model, or SMPL, a standard way to represent the human body with sliders to control its pose. And it's not just for computer vision. The next set of images shows how these tools are just as powerful for robotics. In one panel, we see a robotic arm with controls for interactive inverse kinematics. That's essentially figuring out the joint angles a robot needs to move its hand to a specific spot. Another view shows a policy rollout, which is watching how a learned strategy plays out. In this case, a humanoid robot walking. Finally, they show batched rendering, visualizing dozens of parallel simulations at once, which is incredibly efficient for large-scale experiments. Building on those applications, this next figure really shows how it all comes together in practice. We see a web-based viewer displaying the output from a multi-view reconstruction. The main window has a 3D scene with a point cloud, human figures, and camera frustums, which are those pyramid shapes that represent a camera's field of view. Then you have a separate graphical user interface with buttons and sliders for control. The key takeaway is that both the complex scene and the interactive controls are generated by really simple Python code, which highlights the direct, imperative programming style the authors aimed for. So to really get at what they mean by an imperative style, the authors provide this great side-by-side comparison. The figure shows 4 small code examples. On the left, you see the Viser approach. The code is very explicit. You create a slider, and then you write a function that says exactly what to do when the slider moves. Crucially, your own program keeps running. On the right, they show a declarative style. Here, you just describe the interface you want, and a framework takes over control. The key difference is that Viser's imperative method lets you integrate these visualizations right into your existing scripts, which is a huge advantage. So, wrapping up, Viser offers a really practical solution for researchers by providing a powerful yet easy-to-use library with an imperative, web-based design. It helps accelerate research by making it much simpler to visualize, debug, and share complex 3D experiments in computer vision and robotics. That's it for this episode of